So hello everyone, thanks very much for coming. I'm so pleased to see so many people here tonight because I really didn't think anyone would be interested to hear about the mainframe. And this all started off actually on a forum that a developer from Aviva, Kelvin, who's not here, posted on the NorDev site and talked about the mainframe being the answer to everything, which is the opposite to what people think. x86 and Intel tends to be the answer to everything, and mainframes, who wants to know about them? So it's great to see everyone, and this is why I'm here really. It's just to talk to you a little bit about mainframes, why you should think about it perhaps in a different light. So I'm not expecting everyone to rush out and buy one tomorrow, but hopefully if it just dispels some of the myths and gives you some ideas of what's out there now, you might be quite surprised. But a bit about myself first. So I started computing 30 years ago. I got my first computer, which was this Amstrad, and I taught myself to program when I was typing out listings of games that never worked. I just absolutely loved it and spent hours and hours and hours playing on it. Always wanted a BBC that we had at school, but couldn't afford one. So I've bought my own. I'm assembling my own little computer museum at home. And with not much luck, because most things are broken or gone wrong, so it tends to be more fixing it. And I'm sure interesting about the Raspberry Pi, because I'm trying to get my son involved in it. He's 9 years old, and I want him to get involved in programming and understand computers. And I tried to get him to do a little bit of basic programming, but he wasn't really interested, and he just ended up doing a 10 print Hello Poo or something, and 20 go to 10, so it just filled up the screen with Hello Poo. So that wasn't too successful. And little did I think that, starting from a computer that did 16 colours, 20-ish years later, I'd be going to a computer system that had even less colours. So this is a mainframe menu screen down in the left-hand corner here. Green screens are green screens. Mainframes are not graphics processors. They're not used for any kind of CAD or anything like that. So, it felt like a bit of a sideways step. But actually, when I found out more about mainframes and what they did and what they were used for, it really, really opened my eyes. Phenomenal. So I've got a little short video because you've probably all heard about mainframes in the movie. So this is a little montage that someone on YouTube put together, which I think is quite amusing.
She was in the mainframe. Check the computer. Check the computer.
The mainframe computer.
I access the mainframe.
Check the computer.
The mainframe computer.
God damn it, you're in the mainframe.
He's locked us out of the mainframe.
Who's not connected to the mainframe?
The mainframe is out of the coolant. You can access the mainframe by remote.
I hacked into the mainframe at the bank.
The mainframe.
I can't find a Canadian server. I don't break into the mainframe.
I sent an engineer to check the mainframe.
So they dumped their entire mainframe onto our fax into our computer.
Cross-check that bastard's profile with the mainframe at Mining.
Yes.
Someone's tampered with the POTUS mainframe.
So all we have to do is load it anywhere it's the code in your mainframe will do the rest.
Check the computer.
The mainframe computer.
I access the mainframe.
Check the computer.
The mainframe computer.
God damn it, you're in the mainframe. Data from the mainframe. Data from the mainframe. I can check with the mainframe system.
That would take some sort of super mainframe computer.
There is a vast amount of vital intelligence on that mainframe.
If I can hack my way to mainframe. Patch into the mainframe.
Did you check the mainframe?
Has 18 acres of mainframe computers.
In the mainframe.
Access code to the Zion mainframe. No response, sir. We have a complete mainframe meltdown.
They've only North got the mainframe couplet.
She's been in the mainframe.
Knox used us to tap into Red Star's mainframe.
Anita,
Yeah.
you're gonna run that against the mainframe for me, okay?
Check the computer.
The mainframe computer.
I access the mainframe.
Check the computer.
The mainframe computer.
God damn it, you're in the mainframe.
So, unsurprisingly, the view of mainframes is that they're big, beastly things that take up, this building plus a lot more. But that's not the case. Going back a little bit, so this week was the 50th anniversary of the mainframe. So it has been around since 1964. April 7th, 1964, to be precise, was the day the System 360 was launched. So that was on Monday, 50 years ago, and it did fill a whole building. This is the heritage of the mainframe. However, so the architecture back then really hasn't changed a huge amount to how it is in 2014. Just the size and the technology has changed quite substantially. But really, the underlying principles are very, very similar. Back then, it was used in the big organisations. NASA used it to help with the Apollo 11 moon landings. They used a system called IMS, which is sort of a database and transactional-based system to work out how the lunar module would land and take off. And it's also used extensively for flights and banking. So this was the first computerised reservation system called Sabre. So, you know, it started its life with the big organisations. And to some extent, that's where it's remained. So, you know, you still find these machines in banks, insurance companies, Aviva have got several. And, you know, that is the real bread and butter is with those sort of organisations. This is what they look like. I was in Montpellier, in Poughkeepsie last week, which is about an hour and a half out of New York, and this is where they build the things in an IBM laboratory. So there's two variations. There's a biggish one and a smallish one. It's about the size of an American fridge freezer. So this is what's called the EC12. It's a double door opening, just like an American fridge freezer you buy down the road. And in terms of power it consumes, surprisingly, very, very little. It's going to be more than a fridge, but it's not a huge amount more. And these things come configured in different sizes as well. So, you know, an organisation like Aviva might have a machine this sort of size, but not have all the CPUs enabled in it, whereas much smaller companies would only need the slimmed down version, the single version of the machine. And that's the sort of inside view of it, tarted up a little bit with some blue neon lights. And I know you can't really see much in there, but it's primarily made up of power supplies and cooling, network and disk cards in the bottom, and then the main guts of the machine in here with the CPU and memory. Everything sort of is on trays and sort of slides out and pushes back. And it's basically a rack. It's basically a rack-mounted system, and that's pretty much where mainframe came from. It's a frame-based system. We call them racks now, but back in the 60s it was a frame. And I guess it was mainframe because the main guts of the computer went into this frame. So that's a little bit of a history lesson. I won't go into all this because it's not very interesting, but really what I was saying, around the 60s and 70s, the machine developed, it matured, and where we are today, around here, there's several different models that IBM market. IBM are the only people that make and market machines, but there's lots and lots of software vendors and suppliers that write software. Z Linux being particularly the most notable. So in the early 2000s, some IBM geeks in Germany decided they would try and port Linux onto the mainframe. And what started out as a bit of a pet project suddenly grew massively. Customers wanted to run Linux, and I'll explain a bit later about why they wanted to run Linux on the mainframe. But this came out and it's grown massively. And now a lot of the new sales of mainframe systems are just purely to run Linux. And that's a completely bog standard version of Red Hat or SUSE Linux. Slight tweaks. I think about 98% of the code is bog standard. 2% of the code is compiled to work on the architecture. But other than that, it's exactly the same. So software-wise, you know, there are thousands and thousands of different software products you can run on here, but IBM are the only ones who make them. And for anybody that's interested, that's the sort of processor speed. We don't really get too caught up on this 5.5 gigahertz because it doesn't really mean that much. And people always say to me, well, how do you compare a mainframe to a x86 Intel core? And the answer is you can't. It's incredibly difficult. You can't say that a mainframe running at 5.5 gigahertz is the same as a quad-core Intanium chip or whatever it may be, because of the way this system has been built up over the time. And these acronyms here are some of the reasons why it's so very, very different. So these are all different types of processors. So this is called an MCM, a multi-chip module. So it's basically a big CPU block, about that big, with different there's 6 cores on this one, so 6 cores with 2 doing other stuff, I don't know. And but you can assign different tasks to these machines, to these CPUs. So some of them will be dedicated just to general CPU processing, so doing calculations, running COBOL, all that kind of stuff. But then others will be assigned to running perhaps just Java workloads. And there's something called the ZIP processors, which will say, I recognise this as a bit of Java program. Rather than run it on a normal general purpose processor, I'm going to run it on a specialised one, which has much better pricing and much better software licensing benefits. System assist processors are dedicated just for doing I/O. So rather than the CPU being locked up, doing I/O requests to the disk and waiting for it to come back, the CPU simply says, this person wants to do some I/O, I'll pass you over to my system assist processor, and my system assist processor will go off and do the I/Os for me, and I can carry on and get on with work with someone else. And we go on, and there's IFLs, which are processors, again, exactly the same processors, but they're dedicated to run Linux. These are called Integrated Facility for Linux. So again, again, a customer benefits from better licensing terms, and they can run Linux completely separately to their perhaps their COBOL code that they might have been running for 30 years. There's also capacity on demand, so spikes in workload. And this particular, I said I'd talk about mobile, particularly true in mobile world where we are seeing mobile transactions just go through the roof. Being able to scale up your processor capability just by the flick of a switch is incredibly powerful. And crypto cards as well, so there's CPUs dedicated just for cryptography, for SSL decryption, encryption. And again, these are all things that are freeing off work from the CPU so they can get on and do the stuff that they do best and leave I/O and cryptography to the specialised processors. So these are some of the reasons why it's very, very hard to say that's why a mainframe chip is different. Okay, so sort of goes on to why the mainframe. As I said earlier on, it has really developed with the big global banks, with the big insurance companies. I'm not going to go through all these, but things like 96% of the top global banks run a mainframe. But what I wanted to really make clear to you today is that it's not just that. I've done a few examples here on the left-hand side of companies just in the UK that have bought these machines for specific tasks, mainly Linux. White Cube is a small art gallery in London. They bought one of the smaller BC12 mainframes about 18 months ago. Basically, they were just fed up with system problems they were having. They had to maintain 24/7 availability because they had art galleries in Singapore and China, as well as the US and the UK. And they might not sell many paintings, so you think, why do they want a mainframe that they're not selling thousands of paintings every second? It might be only 2 or 3 at a time, but these are very high value pieces of work they're selling. So having a system that was there and available, and they were finding that if a system went down in the UK, someone that wanted to buy a piece of artwork in Singapore couldn't tell whether that item had been sold or not because the systems need to talk to each other. So that's some of the reasons why they decided that a mainframe would be the best business decision for them. Another small company that's referenced actually in the IT press this week is called L3C. They're a cloud provider, and they've decided that they wanted a small mainframe to provide cloud services. They're an MSC, so they're service provider for cloud. And unfortunately, the quote has sort of got a bit chopped here. But they talked about going for a mainframe rather than x86 for reasons of cost of management. One of the big reasons for moving to a mainframe is you can consolidate lots of virtual servers onto one single footprint. And I'll talk more about that later. Dundee City Council, there's an interesting post that the IT support manager posted, I think it was about 4 months ago. And he says at the end, we still know little about ZVM being the operating system that he runs Linux under. But then again, we don't need to. It just sits in the corner and runs. So some of these reasons around availability, cost reduction, these things aren't as expensive as you might think. They do consolidate so many more times because of going back to the architecture, because of the way the architecture works. You can squeeze so much more workload out of them. You can run them 100% CPU utilization day in, day out, 24 hours a day if you so wish, because they're just designed to be able to work like that. They're real workhorses. Okay. And this slide just illustrates what goes on, because every day there's so much traffic, so many web servers out there, so many ATMs. But just to give you an idea of what the mainframe gets on with. I don't know whether you can read at the back, but it's talking about how many iTunes and tweets and Facebook likes and YouTube views. So unsurprisingly, Google search comes out at the top. So just about 60,000 Google searches every second of every day. And to put that into perspective, so Kix transactions. So Kix is sort of the mainframe flagship application server. I guess is probably the best way to describe it. Stands for Customer Information Control System. It's a bit like a JVM because you can run Java under it, but you can equally run C and C++ under it. You can run COBOL under it. And it's transactional. It's a bit like thinking of an ATM. So you get presented with a screen and an ATM. You press a button, it sends it back, and their program runs in the background and comes back with the result. Maybe a balance check, maybe it's a withdrawal for cash. Kix is very much like that. It's driven by conversation. So you say to Kix, give me this screen. I'll tell it to do something. It'll go back and and come back with the result. But more and more and more, it's being opened up for XML and SOAP and web services. In fact, we've been doing SOAP with Kix in Aviva for at least 10 years, maybe more, John. So a huge amount of Kix transactions around the world, over 1 million every second of every day, and it's developed here in the UK in Hursley in Hampshire, which is where the Kix labs are. They also develop MQ there. You may have heard of MQ series, sort of the highly available, highly resilient messaging service. So that's all out of Hursley. Okay, so the next bit was all around systems of record and systems of engagement. This is sort of a fairly new thing to describe multiple tiers of architecture. So traditionally, companies, big or small, will have something like this. You know, they'll have their consumers, customers, whoever they may be, accessing their systems via a multitude of channels and devices. They'll come through firewalls and routers. There'll be maybe SSL and XML appliances to offload the SSL. Caching maybe, etc., authentication. Then you have your front end here with web servers and application servers. And the companies that perhaps run the mainframe will be right at the very back of the architecture. So that will be where their databases are, where their accounting systems are, all of that kind of stuff. So it's quite a complex infrastructure, and trying to get to your end data. It's going to take a few seconds, which in the scheme of things perhaps isn't much, but when you multiply that by some of the statistics we've seen earlier, it takes a lot of time, a lot of energy. And when people are wanting information right now via their mobile device, they don't want to wait more than a fraction of a second to come back. You don't want to have to trawl through all of this. And then what happens if there's a problem? How do you know whether your web server's gone down, whether it's a problem with the mainframe, or whether it's a problem with your firewall? So what's been going on is sort of a convergence of these technologies. There was a recognition that we really wanted to bring together the presentation layer, or the systems of engagement as they're called now, together with the back end. So there's something called a Blade Center extension, which can plug directly into a mainframe now, and you can run Windows on there and AIX and Linux. So all of your traditional systems of engagements can run in a basically a Blade rack system, but talk directly to the mainframe via a high-speed internal network. And the idea is that you can then manage this sort of pie chart thing here is all about managing the workload as one unit of work. So if there is a problem with the website, you can see right from the start, is it a problem with my Windows front end, with my web server, or is it a problem perhaps with presentation layer? Is it something in my Linux, or is it something in Z, in DB2 perhaps at the back end? So that's all around how do you consolidate infrastructure? How do you save costs by consolidation? Okay, so mobile. This is really such a massive growth area, and for IBM and for all the other companies out there, we're all trying to work out how do we best manage the mobile workloads that are just going massive at the moment. So this system is designed really from the outset to manage mobile well, and we also talk about cloud and analytics in a second, but mobile. So the customers are wanting access to their data instantly, and this all goes back to how do you give them access to systems that may already be on the mainframe. So I appreciate this maybe not for startups, startups that don't currently have a mainframe system, more the bigger companies that do have all of their core customer data, the banks in DB2. So customers want to do balance checks. How do they go and get the instant view of their data? How do they move money between accounts? You don't want to have to get them through lots of tiers of different servers to be able to do that. You want it to be really, really quick. So the mainframe now is designed very much to allow data in. So Kix is the system we were talking about earlier that supports all of the JSON kind of messages that come out of mobile device, JavaScript object notation. And you can configure your mobile device basically to talk directly to Kix now. And I've actually got a demo on my phone which I won't show because it's a bit time consuming. But basically you can connect directly to a Kix system and look at all the live balance, all the live stock inventory, basically anything that's stored on the mainframe. In terms of analytics, so this is big data, to coin the phrase. Hadoop is now, you can run Hadoop on a mainframe. So, how do you handle the structured and unstructured data that's coming out of all the social media? How do you know what your customer's doing? And traditionally what people did in the big companies was to take off big chunks of their data via an ETL process, extract, transform load, take out all this data and then put it into multiple data marts or data warehouses and then run long, complex queries against them. And that's all very well, but as soon as you take the data away from the mainframe, which is in often cases the single version of the truth, as soon as you do that, you've lost the what's the word I'm looking for? The currency of the data. It's old almost immediately. So being able to run all the analytics directly on the mainframe is now absolutely key. And being able to feed into Hadoop or take feeds from Hadoop is now possible as well. So, the key message here is that I want to say this system is, really at the bang of the 21st century. It's not stuck in the 60s. It has evolved massively. It's a bit like a 747. I often use this analogy. 747 jumbo jet was designed in the 60s, not long after the System 360. It was designed to efficiently take several hundred people across the Atlantic at one time. Very few pilots. But you wouldn't go to New York now and think, God, I'm not going to get in a 747 because it's built in the 60s and it's old technology. It's evolved, it's come along with the time, but basically it's still a 747. And really that's what a mainframe is. Its roots all are still back in the 60s, but it's evolved and it's changed, and it now has been modernised to the extent that you can absolutely run for any size business for really any use case you want to. Security, so Heartbleed is an interesting thing that's just been in the press the last few days. Mainframes traditionally don't get hacked, but there have been cases where they've had data losses, where companies, particularly from internal, have let passwords go and people have gained access to it. But the mainframe is probably the most securable system in the world. I'm not saying it's the most secure because at the end of the day, humans have to configure them and have to secure them how they see fit. So there's the tools to make them the most securable. But I think there's only a matter of time before people do start trying to hack mainframes because they know that a lot of critical customer data is in there and the absolute goldmine information. So security is really, really hot on companies' lists. So there's a huge amount of work to be able to recognise security breaches before they happen, being able to predict patterns in what's happening in the system before it's too late and detect them and prevent them from happening. But really, the system is incredibly secure, and it's passed EAL5+, which is sort of the American benchmark for secure systems. So it's already incredibly secure, but it's just worth mentioning that these threats are out there for any systems. Okay, so I'm actually nearly done. Let's run through quite quickly. I wanted to talk a little bit about application development. Because again, it's thought of as a system that runs COBOL. Who learns and writes COBOL anymore? Actually, quite a few. There's still a lot of COBOL out there. And I read only a day or two ago that there's still tens of thousands of COBOL programmers active out there. And obviously there are billions of lines of COBOL. However, people aren't learning COBOL out of university. They're learning Java and they're learning maybe C++ still. I don't know. But it is all around how do we modernise the mainframe to enable all of these languages to be used? And the answer is it's been done and it's been going on for quite a number of years now. Java has been running on the mainframe for 10, 15 years. You may not have wanted to run Java 10, 15 years ago on the mainframe. It wasn't particularly well tuned, but now IBM and the software vendors have recognised that actually it's a damn good place to run Java, and for all the reasons we talked about earlier around the architecture, very, very efficient. And there's still evolutions coming along. There's at the moment the processors aren't multi-threading, so although they can run lots of tasks, in series, there isn't true multi-threading. But multi-threading is going to come along in the next year or so, which will really suit some Java programs. But in terms of RESTful interfaces, the APIs, XML, SOAP, we talked about earlier, all of these things have been around for quite a while, and quite happily you can interface either into your existing systems, or if you're brand new, you don't even have to learn or touch COBOL. The machine can run all these languages quite happily. And you don't need to touch the 3070 green screen anymore, like I showed on my first slide. Most application development now can be done through a GUI front end like this, and a lot of companies are now using this because they recognise that particularly their younger students and younger intakes just aren't taken to green screens. They're used to this kind of interface. They want to use it, so it's now out there and being used quite widely, and has been for a while. So, you can develop your code. It doesn't matter on the language. You don't know really that you're using it on a mainframe, apart from it may talk about ZOS here, which is the operating system. But basically, it's you're developing code and you don't really care where it's running, and that's the whole point. And talking about young people and how do we get people into the mainframe? Because generally speaking, people don't know about the mainframe. They may have heard about it, may not think it's relevant, which is partly why I'm here. But actually, I find that there's a huge amount of interest in young people. So I do a guest lecture at UEA every year, and I go and talk to the first-year computing students, and I generally have very good feedback. And we run a mainframe competition every year, and a massive uptake. Last year, there were over 400, nearly 500 universities that took place just in the UK. Well over, I can't remember the number now, but something like 6,000 students took part in it. Globally, we're talking tens of thousands. And this year, there was, because it was the 50th anniversary of the mainframe, there was a big global competition, a lot of noise made about it, a lot more sort of swell of students took part, big prizes. And there was the world final yesterday in New York, and this is a screen grab from the video that I took today. And basically, UEA were in the top 10, but a guy from the University of Brighton actually came third place, just beaten to the post by a guy from China and another guy from South Africa, unfortunately. But these are computing students that have just decided that they want to learn about the mainframe off their own backs, and have done fantastically well. And the competition starts off quite simple. It just gets people to log onto a mainframe and understand what the hell one of these things are, all the way to creating an application and then demonstrating it to these judges in New York, and showing some unique value that they've provided. So, yeah, I mean, there's absolutely a huge amount of interest, and I don't think, it's just my opinion, I don't think young people have got perhaps the stigma that some of us have got, including me, that have worked in IT for quite a while, and just think, well, some systems just aren't worth bothering about. Other systems are all, the future. I think people now are coming through university not having any sort of preconceptions of a mainframe or an x86 or a power system or a Unix system. To them it's IT, and it's all about mobile and ease of access. And that's why all these themes that we're talking about are being embraced by the mainframe technology now. So yeah, the mainframe's been predicted to die for a long, long time. We've gone from sort of this centralised computing idea in the 60s, where you did need the massive, great machine rooms, and PCs were very, very expensive to buy, and so people had dumb terminals. We've gone from that model to the distributed system, so from sort of the mid to late 80s all the way through to, well, really current day. It's all been about decentralising, and spreading the risk. But the downside of that has meant, especially the bigger companies, have had to have bigger and bigger data centres, rack more and more servers. I know one of the banks I work with who had suffered from one of the public spikes in February of mobile workload. They've had to rack up a load more x86 servers. They haven't had to go and buy a new mainframe, even though all those transactions hit the mainframe, but they've had to go and rack up a load more. And let's face it, electricity prices are not ever going to go down. So these data centres, are really, in the next 10, 15, 20 years, are going to be a massive, massive chain around people's necks. And I think, we are on a bit of a ticking time bomb. And people talk about green data centres, but, these things still cost a lot of money to run. So Again, it's my view. I think we're going to slowly go back to a more centralised model again. I mean, virtualisation has been around for quite a while now, but virtualisation on the mainframe has been here since 1964. And that's one of the interesting things I ask at UEA is who knows about virtualisation, and not many people know or care probably about it. But you know, it was only what, 10 years or so ago, VMware really hit the scene and said, you know, why are you running individual application servers for each of your business units? You know, why does one application have to have its own server? And this was one of the reasons why the System 360 came about, and it was because computers back then obviously were very, very expensive. So they had to share them, they had to share the resource. So these developers in NASA, they wanted to have their own unique area, but they couldn't afford to go and buy dozens of these System 360s. So the whole point of virtualization came about really to be able to share these very, very expensive computers. And that's really the operating system, which is now called ZOS. It used to be called MVS, which stood for Multiple Virtual Systems. Before that, it was System 390 and System 360. But regardless to say, it's always been virtualized. The idea of this single system shared by many, many people, many, many applications, all doing very different mixed workloads. So one application might be doing very batch-intensive workloads, processing bills that are coming in from, I don't know, BT, say for the telephone bills, all the way to ATMs. You know, they're very conversational, quick-fire sort of things. So yeah, where systems have had to be built specifically for applications, the mainframe has always been there, really a bit of a sort of mix of everything. You know, you could throw anything at it. And actually the logo, which is on my front slide, was of a compass. And the whole point of that was it was a 360-degree system. And that's why it was called the System 360, because it could do any kind of workload. So I think the death of the mainframe is probably not, well, I'm hoping it's not going to happen in my lifetime because I want to finish my career out of it. But I think it's here for a long, long time. I think we're going to go more and more back into consolidated models, centralised models, systems that don't use a lot of power, systems that are very highly virtualised, very highly tuned. And it doesn't matter whether you're a small startup or a big financial institution, you know, these challenges are going to be the same wherever you are. And as businesses grow and take off, you know, companies can't necessarily afford to keep racking and buying servers that aren't fully utilised, you know, perhaps 20 or 30% utilisation. It's not very good economics. So the death of the mainframe, I think, is very, very premature. And that's all I had to say. So, giving back some of the evening. Yeah, go on, Dom.
How much are these cost?
I thought that question would come up. It's hard to say because there isn't a standard book that says this is how much mainframes cost. Every customer's different, and I'm not a salesman, so I can't say. And I don't know whether people like White Cube and the L3C company, you know, where they paid list price, but they tend to be around about the $70,000 mark for one of the small machines. But as I said, it does vary so hugely, and I think it depends on individual customers and how they negotiate with IBM probably as well. So, you know, they're not going to be cheapest chips to buy, and this is why the x86 server really was born at the expense of the mainframe. You know, people didn't want to go and spend millions of dollars on mainframes in the 80s and 90s. You know, it was much, much cheaper to buy an x86 server and plug that in and away you go. And to some extent, that's still what most people do. You know, it is, and this all comes down to total cost of ownership and total cost of acquisition. You know, it's a lot cheaper to buy an x86 server. No one's going to tell you otherwise. But what's the long-term cost of running that? You know, it's particularly when you start adding them up. You know, the more servers you have, the more maintenance you've got to do on them, the more power they need, the more racks they need, the more networking switches and routers they need. You know, the list goes on and on and on and on. One good example, actually, of sort of people don't think about maintenance, but Citibank run some of the big EC12 machines. I think they've got 8 of them worldwide. So there's only 8. They've got tens of thousands of x86 servers. But one of their senior directors stood up in New York last night as part of the Mainframe 50 celebrations, and he said, in 6 months, we refreshed all of our mainframes globally. It takes me 6 months just to get one x86 rack. And that sort of says a lot, really. You know, I've worked on projects where we've gone from Windows 2003 to Windows 2008. We've gone from 32-bit to 64-bit. and it's taken years and years and years and years of effort to get applications to behave with them, to get them to virtualize properly. And often you end up with servers that are still dedicated to applications because the applications need a lot of change. So you start adding all this cost into the business to be able to upgrade servers. And again, it becomes incredibly expensive, but they sort of get hidden away. Whereas on the mainframe, one of the founding fathers of System 360 said, it's our intention in IBM that a customer will never have to change their application code because of a change that we make to our hardware or software. And not fully, but to a lot of extent that's still true today, because there are programs that were written 20, 30 years ago. I know there's code I've written still running out in Aviva that doesn't change, and yet the technology is refreshed, and that's why City were able to refresh in 6 months. You know, they didn't.
That.
You what? Sorry.
Branch round your code.
Yeah, well, you probably. Yeah. Yeah, they just stubbed it. So yeah, that enables customers to be able to keep running their code, you know, really sweat the asset, not have to rewrite their business logic that's there, and that saves an absolute fortune. So I've sort of given you a bit of a politician's answer, but yeah, about $70,000 is the rough mark.
What can you run on a $70,000 mainframe? Can you run Twitter? Can you run eBay?
Can you run Doom on it?
I think the answer is it would depend on the application.
That's what I mean. So what sort of application?
Yeah, well, pretty much anything. So you know, you could run. So customers like Whitecube are just running a small mainframe, running Linux. I don't know what their application is. I'm guessing it's something that's been written in Java. I guess it's in-house. I don't know. I'm guessing. But no, I mean, pretty much anything you like. Off-the-shelf packages tend to be a little bit less supported on the mainframe and on Linux on System Z. So, you know, not every vendor out there supports them, and that's always a challenge that comes back to say, well, we run so-and-so package, so and they won't support it on the mainframe. What do we do? And the answer is that sometimes we work with the vendors and help them, and you can actually run the mainframe on a laptop now, and I've got it running on mine. So we sometimes say to the software provider, here's the mainframe software on your laptop. You know, you go and develop it. Oracle are a good example. They've got a team of people in Reading that port the Oracle database product onto the mainframe, and a lot of customers are now running Oracle onto Z Linux. So, but it does absolutely depend. But what you absolutely do get is this consolidation. So, you know, $70,000 sounds a huge amount of money, and it is. But you can consolidate perhaps, well, again, it depends on the application, but we say a roughly 30-to-1 ratio, 30 x86 servers to one integrated facility for Linux chip on the mainframe. But it can be a lot more, it can be less. What tends to suit the mainframe mostly is sort of the I/O type of transactions, because that's where its roots are. The high complex calculation type of applications aren't really a good fit. You know, that is more suited to perhaps a Unix type of system or an architecture, or maybe Windows. So no, heavy-duty, complex computational things you wouldn't necessarily run on there. Saying that, the Met Office have got a video as well. They're running a lot of their stuff on the mainframe. But I don't think they're doing complex weather forecasting on it. Does that help? Yes.
Do you envisage mainframe on the cloud? An Amazon-style purchase?
Do you know what? Yeah, so that was on one of my previous slides, and I didn't really talk about it. Cloud, yeah, very much so. That's one of the key things that's going to. And actually, IBM only yesterday announced an enterprise cloud platform that they're going to offer, and the details are still coming out. But basically, the idea is that they provide customers with a standalone small box just dedicated to running cloud, and it will have the provisioning software on there, the management software on there, all preloaded, ready to go. And the idea is you stick one of these in your corner of your data center, and it will just run and run and run and run, but you can manage cloud services on it. But actually, you know, it depends on your interpretation of cloud, because again, it comes back to virtualization, how these systems are managed.
Well, that's what I was talking about. So you know, go to Amazon and say, I want to buy a
Yeah.
mainframe rather than the
Yeah,
70,000
yeah. Yeah. And that's what L3C, that company, do. So they sell cloud services, and they offer mainframe cloud services if you want it. But yeah, whether it's a public cloud or private cloud, basically it can do both. Customers that want the security of a private cloud and knowing that their data is going to be in their data center, then absolutely this system is designed for that. And you know, this provisioning application services on the mainframe this has been the bread and butter since the 60s. So in terms of how cloud has sort of evolved, it's not really very different from where the mainframe was 50 years ago. But no, it's very much now seen as, or IBM wanted to be seen, I should say, as a cloud platform. And it's all the reliability, availability, all of that kind of stuff.
If you were just getting a load of Linux servers, and you dial into who your provider is and you set them up, and you say whether they're running on x86 and whether they're running on the mainframe.
You'd care if you lost the service.
I appreciate that.
I get
for a practicality point.
for a practical
the mainframe might be more available and more reliable.
Yeah.
Do you really care as long as you've got a Linux box that works the way you expect it to?
No, absolutely no, absolutely not. You wouldn't, and that sort of goes back to that other slide I said about developers not caring where it goes to. They're developing some codes. They don't care whether it's a Linux on x86 or Linux on the mainframe. So no, absolutely right. But when it comes to deciding what your non-functional requirements are, that's not going to be a developer's decision. But perhaps if you're a CIO or an IT director, CIO, you're going to want to know that your cloud service that you're buying is going to be secure and resilient and available. It's all of those abilities of that the mainframe is really core. Its core bread and butter is not going down. And not really a cloud example. City stood up yesterday and said that their ATMs that run off the mainframe have been up now for over 4,500 days with absolutely zero downtime. I mean, it's just, these things are just rock solid. They're built from the bottom up. They're a bit like Apple devices. I often say this. They're a bit like the iPhone, the iPad. Love them or hate them. They generally do work incredibly well. You very rarely have to reset your phone. My iPhone I leave on most of the time. Occasionally I have to switch it off, but generally speaking, it's there. If I want to make a phone call, it works. If I want to check my email, it works. The bad side is that it's locked down, that you can't do much with it, and it's expensive. But that's big. Apple have made this conscious decision, haven't they, not to allow USB or SD cards, not being able to let the user take it out and put their own memory in. And that's because they've designed the architecture from the ground up, from the hardware all the way up to the software to work reliably in first time. And that's kind of what the mainframe is. So, IBM have designed the hardware. You can't go in and change the memory for some memory you found off eBay. Well, you might be able to, but you probably invalidate a huge amount of warranties. And the system does just work. So no, you don't really care where it is unless you have problems. Yeah,
If you compare it to the cloud, it's almost like you've got this whole title there that says it's for startups, but you see the start thing is you don't know how. You want to keep your costs low, and you don't know the demand or how busy your app is going to be.
Absolutely.
So you might have spikes here and there and all this demand.
Yeah.
So it kind of feels really enticing just to go with someone like AWS or Google or Rackspace and so on, rather than thinking that you're going to buy 70 grand on a box and you don't know what your requirements are to spec out.
Yeah. I hear what you're saying.
Like,
Decision. And I totally agree with you. And that's probably what Facebook said, and all these other that started out in what's his face's university dorm, having a mainframe to run Facebook probably just seemed the most alien concept and idea ever. So no, you're absolutely right. How would you go out and buy $70,000 worth of kit to run a new business that you didn't know whether it was going to, whether you'd never ever need this kind of capacity or reliability? And the answer is probably no, you wouldn't. No, you probably would go and buy a service from the cloud or from one of these people and that's why companies like this L3C, whatever they were called, offer this kind of service. So it's a bit of a best of both worlds. Someone has the upfront cost of buying a mainframe, and people can consume it, on demand. And know that they're benefiting from that reliability and availability. But it's when the business starts to grow, I think, that's when decisions might be made. You might not have a data center, but you might have a floor where the floor is really beginning to fill up with racks and servers. Those servers start to become end of their life cycle and need refreshing. That's the sort of time when you might start deciding, well, should I be just refreshing all of my x86 estate or whatever it may be, or should I be thinking about something else?
So if you're in the cloud, you wouldn't even have to think about that, would you? Because the idea
if it's public cloud,
you design your software to be independent of the hardware, so that it will always just either load balance or be disposable.
Yeah.
So you can just chuck away the old hardware and just redeploy your software on the new one. You can even make that part of the deployment cycle, and it's, I don't know.
You could, yeah, absolutely. No, so let's assume for a minute it's a private cloud and you've got your own, downstairs on floor one, there's a room this size full of servers. Yeah, you're absolutely right. The application isn't going to care if you swap out all your racks of servers and replace them with the new shiny ones, except it might care if the architecture suddenly changes and it's sort of 64-bit, it's now 128-bit, or I don't know, you're running Windows 2008 as the operating system, and Windows 2015 comes along, whatever it may be, and suddenly now the application doesn't play nicely with it. And I overheard the guy earlier talking before we started, saying about Windows XP Service Pack 3 only supporting certain bits of the mobile stuff he was developing. And anyone running less than Service Pack 3, the code is going to fail, and he's now got to do application rewrites. XP has now been sunset as of yesterday, wasn't it? But there's people going to be running XP for a long, long time. So I guess what I'm saying is, you're absolutely right. If you've got a private cloud, in theory, swapping out hardware for identical ones sounds simple and straightforward, but it might be costly if the application isn't quite as transparent as it ought to be. If you're buying public clouds, it's not your responsibility to buy the hardware anyway. So, what's the point? Well, the point of that is, do you trust Amazon or Google or whoever it may be with your data and with your service, particularly if you're starting to grow? Is that actually going to be cheaper? So I haven't got it with me, but we've done a study where we compare Linux on System Z with cloud with Google and cloud with Amazon. And it's just buying basic cloud services with WebSphere software, so running a fairly simple website and a database system as well. And it's all published prices on Amazon and Google's site. And the cost stays quite level for Amazon and Google, whether you've got 1 or 1,000 virtual machines. With Linux on System Z, it does start off higher because obviously it's a higher acquisition cost, but as soon as you start scaling, the price just comes down like that massively. So suddenly it becomes commercially a lot more of an attractive proposition. Plus, if you've got your own personal machine, then you know that data's there.
I think you just answered that.
Yeah.
After 70 grand startup, setup cost, is there then a yearly license? Is there
just normal software? Well, I mean, I think there's options around hardware maintenance. You can either choose to have it or not, and then if you do, IBM will come and maintain it, and if there's a hardware problem, they'll fix it, just like any other kind of vendor solution. And then software would just be the normal software costs. If it's Linux and you buy it from Red Hat or you buy it from SUSE, that'll be whatever they charge. And again, they might charge nothing, or you might decide that you want to buy support. That'll just be their normal costs. Costs for the traditional System Z software, so Kix and DB2, and I mentioned IMS earlier on. They're not cheap bits of software, and that no one's going to say that otherwise. So it does tend to be the big banks that can afford to run these millions of Kix transactions every day. They're not going to be cheap and straightforward. But again, it comes down to what business value are they getting out of it. But no, going back to startups, it's going to be, it's no different to whether you're running Linux on x86 or WebSphere on x86. It's all the same, or pricing is all exactly the same, and it depends on the vendors. Oracle have got their own pricing model, and actually, strangely enough, you think Oracle and IBM are competitors, they actually have a licensing model that favours the Linux chips on a mainframe. So they publicly got rid of HP support 2 years ago for the Utanium chips, I think it was. So they said, no, we're not going to support you on HP anymore. So that was a real blow for people that were running Oracle on HP chips. Suddenly it became a lot more proprietary. You had to run Oracle on certain different types of chip, or preferably on Sun systems, which obviously Oracle own, or you buy their Exa systems. And absolutely no problem with that. That's their business model. But they support the IBM Z system, which is fantastic for us because it helps us grow, and it's good for the customers because they've got the choice of keeping Oracle and not having to migrate to another system. But yeah, no, it's software costs are the same.
Did you find a minute ago that you can run Windows on the mainframe?
You can. So on one of these blade centers, which was on one of my early slides, this one. So this is all about this converged, consolidated infrastructure. So if you've got a Windows front end and you want to talk to something on the mainframe, you can basically plug it into this is just a chassis, it's just an empty rack, and you plug in a normal x86 blade, install normal, absolutely 100% untouched Windows Server, and I think 2008 R1 is the one that's the sort of lowest level supported. Excuse me. You plug it in, put your application on, the application doesn't change, but what's happening is that this management facility straight away takes control, and there's virtualization hypervisors on here. It uses KVM, so straight away it recognises that you've plugged a blade in here running Windows, and it says, right, okay, I'm going to now understand and manage your application, and then any talking it does onto the mainframe is all managed as sort of one entity, one unit of work almost. So for companies perhaps that have got a website that's running on Windows, all their front-end traffic comes in initially into the Blade Center, running on Windows, and then as soon as that website, perhaps it's a postcode lookup is a good example. Perhaps they're doing a postcode lookup, they're doing a quote for home insurance, type in their postcode, the postcode request comes into here, into DB2 that's running on the mainframe, the postcode result comes back to the Windows server, and that gets displayed to the customer.
It's not actually Windows running on the mainframe?
It's not Windows running on the mainframe, it's Windows being managed by the mainframe, but it's physically located and connected to the mainframe. So yeah, it's called Z Enterprise. That's the Z Enterprise thing at the top. It's the idea that you run your whole enterprise as one logical unit.
So I suppose if you were really that way inclined, you could run Linux on the mainframe,
Yeah,
and then run VMware or something on Linux,
Yeah.
and run Windows on that?
yeah, you could. Yeah, you could run. Yeah, on this side you could. But on this side, you probably wouldn't. No, you wouldn't run VMware on a native Z series box. But you could, there's no reason why you can't run VMware over here.
x86. Well, this is what I was thinking, that's what I was really trying to get to. But
Yeah.
I bet to run DOSBox.
Yeah. Okay. Any other questions? Yeah, sure.
Would you say that mainframes are more performance per watt then? You said they're more energy.
Yeah, absolutely. I haven't got like a rule of thumb. I couldn't say to you that for every 10 watts of electricity, you can do the same amount of computational power that you could on 50 x86 servers, for example. Again, it'd be a really, really hard thing to measure. But generally speaking, yes, it is. These systems, I wish I'd brought the statistic. It's not much more than a kettle. It's not much more than about 3 or 4 kilowatts for one of these systems. A fully loaded one, these things can take something like 112 CPU processors. I guess if you had all 112, all running 100% hot all the time, then it's going to be probably a lot more than a kettle. But still, incredibly energy efficient. Yeah, these things have been designed really, really with energy efficiency in mind. So the amount of work you can do for the amount of energy it's consumed is phenomenal, really phenomenal.
Air conditioning you have to run as well.
Yeah, they don't run that hot either. But yeah, actually. Well, exactly. Yeah. They don't run that hot. Actually, and there's a water cooling option. More and more data centres, I'm hearing, are running water cooling now. We've gone from water cooling in the old days to air cool, and now people are going back to water cooling. And that's, I think that's partly because chips are it's Moore's law. They're trying to run faster and faster and faster, and they've got to a limit where they can't run much faster, but they're running hotter as a result. But no, these things have been designed to run cool and energy efficient.
It's like my fridge, are they like A rating?
Actually, that's a good idea. They ought to be. Yeah, have a little sticker here, A+.
So if they're not very good at computation intensive stuff, I take it they're not very good at Bitcoin mining.
Probably not. No. No. Not until quantum CPUs come in. Then maybe they will.
Is there any option you can do with the rack thing on the side to get CUDA chips in there and maybe have?
The architecture is exactly the same as this normal blade. So these are normal standard blades. So no is the answer. The IBM haven't really deliberately didn't want to touch this architecture at all. They wanted customers to say, we're just going to run our standard blades in there. And that's what we've done. You know, I think if IBM started to play around, not only would it suddenly become proprietary hardware, you know, and you could only run, you know, certain hardware in that machine, but also applications may then have started to have to change. So, yeah, no, they're standard. Okay, well, hopefully it's given you a little bit of a flavour, a bit of an idea of what a mainframe is. It's not all ancient dinosaur technology, as some people might well think, and indeed, before I started work on them, I did. I couldn't believe it when I got put in front of this green screen. It was just so alien and completely, you know, it seemed to be completely and utterly daunting and stupid about how this thing worked. But as soon as I started to understand it and realise that there's a lot more to it than it seems, the more I started to think, actually, yeah, there's a lot to be said for a mainframe. So.
Do you know what those competition entrants actually built?
I don't actually know. No, it's probably on the website. There's a website that details all of them. So yeah, I can find out if you like.
That's just pure interest.
Yeah. No, I don't know.
Would anyone be interested in a mainframe hands-on workshop?
Bloody hell, that's keen. 3 people? 4? John, you already know.
Do you rather run your Windows inside a Linux?
So can you do it as a virtual machine on a laptop?
You can.
You're doing?
Yeah.
So
Yeah.
I could get a virtual machine and try it out.
Yeah. So all I've got in here, if I had time, I'd show you. I've got VMware. I've got Linux, a Linux image, bog standard Linux, SUSE Linux image, and then the ZOS, the operating system emulator, runs on top of that. But to all intents and purposes, it's a fully functioning, normal mainframe that the biggest bank or the biggest insurance company would have, but running on a laptop. Obviously, it's restricted.
You could actually sit it on there, call it Xeon, and then hack into
I could hack into Xeon. In fact, it's a good idea. Yeah, if I'm bored one night, I might do that. But yeah, and customers often say, well, why do we need to buy a mainframe if we can run it on our laptops or on our desktops? And the answer is, you can't get all the quality of service on a laptop or on a desktop or on a blade, because you can run it on a blade as well. You can't get the quality of service because it isn't, because you know it's at the end of the day it's emulated on x86 architecture, so you can't run it at 100%. You can't expect it to be up for thousands of days, etc., etc., etc. So what it's good for is for unit tests, for early development stages, for trainees to have a play around, because you can work in a completely safe environment. You can do your unit testing, you can do your early development of code, have a play around, know that you're not clocking up CPU on the main system, and knowing that you can't break anything. And then when you're ready, you promote the code through in the normal application lifecycle. And there's a lot of big customers now that are doing that very early code testing and development back on their desktops or on their laptops.
There you go, you can have Windows emulating Linux, emulating a mainframe, emulating Linux, emulating...
You could, but it'd do your head in.
Just a rabbit hole code.
Yeah.
The real question is why do anyone want to run Windows in the first place?
Well, yes.
Yeah.
Just thinking about as a without the actual physical connection, can we run application remotely? Does it have any region limitation, like kind of cross-country?
Do you mean so? What if you had an application that wanted to talk back to the machine?
Yeah.
No, it's just over IP. They have basically Ethernet cards in the machine. They're not called Ethernet. They're called something else, but it doesn't matter. And you just plug them into your network, and that's it. Away you go. How secure you make it depends on you and the company and where you've got it, but then the limitations are on your network. So no, plenty of people, plenty of big, especially the big customers, are running perhaps just like City is a good example. I said they had 6 or 8 mainframes, I can't remember what, but that runs their global operation. So I think they've got UK, Frankfurt and the US, but they've got customers everywhere, everywhere from Korea to Singapore to China to Australia, global, but they're all talking back to the mainframe hubs.
You mentioned that Citibank had about 4,500 hours of uptime there.
Yeah,
and that's
on their ATMs. Yes. Yeah.
Is that sort of... Sorry?
That was days, not hours.
Oh, sorry, days.
Days, yeah.
Yeah, is that sort of an exceptional amount of time, or is that considered very blasé?
No, So a lot of customers don't sort of publicise how much uptime they have. City were just really good that they came out with it yesterday, and that's why I can share it with you. But no, that's you'd have to be fairly unlucky. I mean, I've been working on mainframes mainly at Aviva for 13, 14 years before I left for IBM, and I only was involved in probably 2, maybe 3 major problems and that was down to things like power loss, UPS is not kicking in properly. I know that there was one instance that was a hardware failure, but incredibly rare. Touch wood, that 4,000 odd days is fairly industry standard. It's and again, that's why you pay extra money. It's why you pay extra maybe for an Apple device. You're paying for that knowledge that the phone or that iPad or that Apple Mac isn't going to fail on you. It's going to keep going through whatever.
Does it have its own built-in resilience?
I wasn't going to go into resilience. It does. The hardware-wise, basically, there's 2 or more of everything. So lots of redundancy inside the box. All the memory is designed RAM and designed for failover. But from an application point of view, you can cluster these boxes together. So you can have 2 or 3 or more of them. And then, I don't know whether you know Veritas Cluster or Windows clustering, but it's called Parallel Sysplex. You can basically run an application that will come in and it will be workload balanced to whichever machine or whichever logical partition on the machine is available, like a VM. And you get application resiliency that way. So there's both hardware and software resiliency. Okay. Pub. Thank you.